Hello friends, welcome to my YouTube channel. Let us start with the 11th problem, exercise 6.5. An aeroplane leaves an airport and flies due north at the speed of 1000 kilometers per hour. At the same time, another airplane leaves the same airport and flies due west at the speed of 1200 kilometers per hour. How far will the two aeroplanes will be after 1.5 hours? Hello friends, let us go to the 11th problem. Let us see. They have said one aeroplane is flying in the north direction. It has a speed of 1000 kilometers per hour, and say this is a starting point, and at the same time there is one more aeroplane which is flying in the western direction and the speed of it is 1200 kilometers per hour. So 1.5 hours later, say if this aeroplane reaches this point and say this aeroplane reaches this point, so the problem says that you have to calculate this distance. Now let us see that A and B. So this is the distance that is required to be calculated. So if they are going in the north and south direction, this angle which is there in between the two from the starting point is 90 degrees. If it is 90 degrees, then AB is a hypotenuse. So using the Pythagoras theorem, we'll calculate this AB. So the speed, so we'll start with the problem. The speed of first aeroplane that is given to us is 1000 kilometers per hour, and the distance traveled, time given to us is 1.5 hours, and distance traveled by the first aeroplane is speed into time. What is the speed? It is 1000 kilometers per hour and 1.5 hours is the time. So the distance traveled by the first aeroplane is 1500 kilometers. So after 1.5 hours, the distance traveled by first aeroplane is 1500 kilometers, and the speed of second aeroplane is 1200 kilometers per hour. So 1200 kilometers per hour. So distance traveled is speed into time again. The speed is 1200 kilometers per hour into time is 1.5 hours. So it will be 1800 kilometers. So 1.5 hours later, this aeroplane will travel 1500 kilometers and this aeroplane will travel 1800 kilometers. So according to the problem, the required distance to be calculated, found out, required distance is AB. So in the right angle triangle, in a right angle triangle, ABO, by using the Pythagoras theorem, we get AB square is BO square plus AO square. We have found out this BO as 1800 kilometers. So it will be 1800 square plus 1500 square. So AB square. Now if you multiply 18 into 18 is 324, and these 2 zeros, 4 zeros, and 15 into 15 is 225, and these 4 zeros. So AB square, the distance that is required. So AB square, if you add both the things, it will be 549 and these 4 zeros. That is 549 into 10,000. Why 10,000? It is 100 into 100, and we'll find out the factors. 549, as here there is odd number, so 3 1s are 3, 3 8s are 24, and 3 3s are 9, 3 6 are 18, and 1. And this 61 is a prime number, therefore this number will be 3 into 3 into 61, and this is 100 into 100. So AB will be, if this is 2 times, this is 2 times, you can write it once, 3 into 100, and this is a single number, therefore we take it in 61. So AB, that is the distance traveled by both the aeroplanes, is 300 and root 61 kilometers. So this is the distance these both the aeroplanes will travel. We'll go on to the next problem. The next problem says, 12th problem, 2 poles at a height of 6 meters and 11 meters stand on a plain ground. If the distance between the 2 feet of the poles is 12 meters, find the distance between their tops. There are 2 poles, this is 6 meter and this is 11 meter. The distance between these 2 poles is 12 meters, and they have asked us to find out the distance from here to here. We'll name them. We'll write down the name A, here we'll write down B, here we'll write down D and C, and we'll draw a perpendicular. Here we'll draw a perpendicular from C, and we'll name it as E. So the next problem, 12th one. So we'll say poles AB, this is one pole is 11 meters, second pole CD is another pole which is 6 meters. So, and DB is the distance between these 2 poles. Distance between 2 poles, that is 12 meters. When we draw perpendicular, CE is equal to DB, because these are parallel poles. So CE is DB, so that will be 12 meters. And if this is 6 meters, then EB will be also 6 meters. EB will be equal to CD, that is 6 meters. So we have to find out this. This is 12 meters. So this is 6 and this is, so we'll write down AE is AB minus BE. AB minus BE. So that is AB is 11 meters. BE or EB we have found out here. This EB is 6 meters minus 6 meters. So this is 5 meters. So AE we have found out here as 5 meters. So if this is 5 meters, then we have to find out CA. Then this is a right angle and this is an hypotenuse. So in a right angle triangle, ACE, angle E is 90 degrees. If this is 90 degrees, then CA square, this is the hypotenuse, is CE square plus AE square. So CA, we have to calculate the distance between the topmost part from the two poles. So CE is 12 square plus AE is 5 square and CA square, 12 square is 144 plus 5 square is 25. You add both, so it will be 169. CA square is 169. If that is 169, then CA will be square root of 169. CA is 13 meters. The distance between the topmost part of both the poles is 13 meters. That was the thing that was asked. So that's all for this video. I hope you have liked and understood today's problem. Share this video with your friends and classmates. And if you are new to my channel, don't forget to subscribe my channel. We'll meet back again with a new video next time. Thank you.